Alright, so if you're watching at home, I'm pausing the study.com video and I'm going to explain how they got here because they skipped some steps. He does real good other than this, but he skipped some steps. He talked about SOHCAHTOA, and there you go, SOHCAHTOA, and how this is kind of code for the formulas for these trigonometric functions. So you've got the names of the trigonometric functions, sine, cosine, and tangent, there with the S and the C and the TR. And all of this in between O and H and A, all those stand for the names of the sides of the triangle, which you got them labeled right here. Hypotenuse is always the longest side, and the angle is here, and this is only for right triangles. That's a right angle there. So this is the adjacent side because it's next to that one, and this is the opposite side because it's across from that angle, or opposite from that angle. Anyway, how they got from here to here is a little weird. What are y'all crinkling back there? Second time the crinkling's been on the video. Come on. So, let's say that this side, why are they saying V? It's for velocity, right? I guess. So, let's say that this is 5 meters per second of velocity on this side. This stuff, these things have to have direction because you've got X direction and Y direction components of this force, or velocity, or acceleration. It's got to have direction, so it can be any one of those vectors, and we'll learn more vectors too, though it could be, but we're trying this out. Are you paying attention back there? Well, if our hypotenuse is 5, I'm glad we got our sides labeled. This is going to help us out here. Let's do this part so we can see how they got this stuff. We're going to solve for the opposite side, and we've got the hypotenuse side. So we're going to use this 5, this hypotenuse side, to find the opposite side. Because we're using H to find O, looking at SOHCAHTOA, that means that we'll use this one that has the H and the O in it. So if it's SOH, that translates into the formulas here. Sine of the angle equals opposite over hypotenuse, and that's what we got written. Sine of the angle is opposite over hypotenuse. It's the same here. Cosine of the angle is adjacent over hypotenuse, and tangent of the angle is opposite over adjacent. But we won't use this one as often as these. Anyway, let's write our stuff down. Let's say this angle is 10 degrees or something. And let's plug that into our formula. So this, I don't know if he said this, this little guy right here. Are you looking? Jada? Ellen? Jada? Jada?
I'm texting my mom. It's important.
JJ? This is a theta. Okay, I'm done. Good. Thanks for looking.
It's a what?
It's a theta. It's a Greek letter. So that represents the angle. So that's where we'll put our 10 degrees. When you do this in a calculator, you need to make sure your calculator is in degrees mode. Otherwise, it's going to mess it up. It'll either be in degrees mode or radians mode. So it might say deg or rad for degrees or radians. So if it says rad, make sure you switch it into deg or whatever. Your app or your settings on your computer calculator or your calculator, whatever you got. All right, let's plug in our other things. We did the sine of the angle. We put in our angle as 10. Opposite over hypotenuse. We're looking for opposite, so I just write op. I would recommend against writing just O because then it looks like a 0, and you're going to mess yourself up that way. Hypotenuse is, we know that one. That's 5. 5, and it's meters per second in this case, I guess. Meters per second. So to solve this, we do just like regular. We need it to say equals opposite. It says opposite divided by 5. So we're going to multiply both sides by 5 to make that 5 cancel. Since it says divided by 5, we're multiplying. So one on bottom, one on top, they cancel. I got to do the same to this side. Notice I did this to this whole thing. This sine of 10, if you put sine of 10 into the calculator and press enter, it's going to give you a number. So please treat this sine of 10 as though it's already that number. You're not doing this 5 times just the 10 because you can't say 5 times a letter, 5 times a word. You know, you're not going to say sign, or however many times. Was that 5? So people want to say 5 times 10, but you can't take the 10 out of there. This whole side has to stay together. It's sine of 10 degrees. So if you put this whole thing in now, 5 times the sine of 10 degrees, it tells you that that's 0.9 or something, I think. And that's still meters per second, because what we found out, if this is 5 meters per second this way, what we're finding out now is that the vertical component is 0.9 meters per second. Like if you were looking at it edge on, where you can't see it going at an arc, you can just see it going up. Like from this way, it just looks like it's going up. You would measure that as 0.9 meters per second. But anyway, that's how they got this. We ended up with 5 times the sine of the angle equals the opposite side. That's how they did that. V times the sine of the angle equals Vy. This is what they're calling the opposite side, is Vy. They're using different letters from us, but we did the same thing. And I'll show another example for the next example that they do. And let me see if I have to pause, if I can pause this video. He skipped the same steps over here, so I'm going to do this one. If I can remember to bring my marker over here. So he got here just the same way we got there. I'm going to do pretty much the same thing, except this time, instead of solving for the vertical side, which we used sine for last time, it's not always going to be sine, because in both these situations we've known the hypotenuse side. It says F is 200 Newton. Here's F. These are different. It's newtons this time, which is a different vector. Like I said, it doesn't have to be meters per second. It could be meters, which would be displacement, not distance, because these all have direction. Let's put our SOHCAHTOA up here. So, all right. Let's solve for this side, which is different from what we did before, but keep in mind we're using the same one. It might give you the opposite side, and then it might have you solve for the hypotenuse. I'll show you one of those on another day, but it's not always going to be sine for this side and cosine for this side. It's just, that's the way it's set up here because we know this one. Anyway, let's see how they got this. We're trying to find this adjacent side. I always like to label the sides of my triangle. It was already done last time, so we didn't have to do it, but now we should. So this one's next to the angle, and this one's across from the angle or opposite from the angle. So I can label that up here, and then it won't be in the way. Okay. I've got the hypotenuse side, and I'm looking for the adjacent side. So I'm going to use H to find A. Looking at SOHCAHTOA, H and A go with this one here. So I'll use this CAH to translate into the formula for cosine. CAH. So cosine of the angle equals adjacent over hypotenuse. Now I can plug in my things. My angle is 30 degrees. Make sure your calculator's in degrees. The adjacent side is what we're looking for. And the hypotenuse is 200. So just like we just did, it says adjacent divided by 200. We want it to say equals adjacent, so we want to make that 200 cancel. Since it says divided by 200, to make it cancel, we'll multiply by 200. One on top, one on bottom. And I'll do the same thing over here. Since I multiplied on that side, I got to multiply on this side. Remember, this whole thing stays together. So you're multiplying 200 times cosine of 30, not just 30, not just cosine, the whole thing. And if we plug that into the calculator, it'll give us 173 newtons. And there you go. I hope these extra stuff help you all with the quiz on this. This one you should take the quiz for. The one that said first on today, that one we don't need to take the quiz for.